Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will review everything you need to know for the upcoming test. So I'll go through all of these 5 topics here, starting with perimeter and length. So the perimeter of a two-dimensional shape is the length around the outside of the shape. So let's say I want to find the perimeter of this shape here. I just need to add up all of its side lengths. Now, sometimes you won't be told all the side lengths, you will have to calculate them. So if it's 8 centimeters from here to here and 3 centimeters from here to here, this side here must be 8 plus 3, which is 11 centimeters. Now, for these two sides here, I can't actually know how long they are. What I do know is that this side plus this side must equal 12. It could be 3 and 9 or 4 and 8. I don't know. All I know is this side here that I'm going to mark in red plus this side here that I'm also going to mark in red add to 12. So the perimeter of this shape, those two red lines make up 12 centimeters. I've also got a side that's 8 centimeters, a side that's 3, another side that's 12, and a side that is 11. So adding up all of these sides, I get 46. Now, perimeter is measured in units of length. Millimeters, centimeters, meters, or kilometers. Because all of these measurements were in centimeters, my final answer will be in centimeters. It is 46 centimeters around the outside of this shape. So you also need to know how to convert between units of length. To do that, follow this chart here. So if you want to go from millimeters to centimeters, you divide by 10. For example, if you want to go from kilometers to meters, you times by 1,000. So the rule is if you want to go from a larger unit of measurement to a smaller one, you multiply because there are more of the smaller unit. If I want to go from meters to centimeters, I times by 100. I times because centimeter is a smaller unit of measurement. There are more centimeters in the world than there are meters. On the other hand, if I want to go from a smaller unit to a larger unit, say from millimeters to centimeters, I divide because there are fewer of the larger unit. So make sure you know this chart here. So I've got my perimeter of this shape as 46 centimeters. So if I wanted to write the perimeter in meters, to go from centimeters to meters, I divide by 100. So the perimeter is 46 divided by 100. You can use a calculator if you want. It's also 0.46 meters. These two lengths are exactly the same length. If I wanted to say, write the perimeter in millimeters, well, to go from centimeters to millimeters, I times by 10. So 46 centimeters times 10 is 460 millimeters. So all of these lengths are exactly the same length. Let's now look at area. So the area is the amount of space inside a 2D shape. 2D means two-dimensional. You need to be able to find the area of a rectangle, parallelogram, and triangle. Each of these is a two-dimensional shape. It has 2 dimensions, length and width. It goes this way and this way, but it has no depth. So to find the area of each of these shapes, use the relevant formula. For a rectangle, just multiply together the length and the width. For a parallelogram, what you need to do is multiply the base by h. Now, h here is the perpendicular height. So perpendicular means 90 degrees. It's this height at 90 degrees to the base. The formula for the area of a triangle is very similar to that of a parallelogram, but you have to divide by 2. When you're finding the area of a triangle, always divide by 2. It's base times, again, h means perpendicular height, height at 90 degrees, times these two together and divide by 2. The reason you divide by 2 is a triangle is always half a parallelogram or rectangle. So let's find the area of each of these shapes here. So firstly, this one, this is a square. A square is actually a special type of rectangle. So to find the area here, you just multiply the length and the width. So these dashes means all sides are equal. The length is 6, the width is 6. That happens with a square. So the area is just 6 times 6, which is 36. Now, when you're writing units for area, it's square units. So this will be centimeters squared. Another way of thinking of this is I could fit 36 little squares of 1 centimeter squared inside this shape. So here we have a parallelogram. I know it's a parallelogram because it's got two pairs of parallel sides. So when I'm finding the area of a parallelogram, all I need is the base times the perpendicular height, the height at 90 degrees. I don't need this 12 centimeter side here. It has nothing to do with the area. So the area is just 10 times 8, which is 80. Once again, the units will be centimeters squared. So let's find the area of this triangle. When you're finding the area of a triangle, you must remember to divide by 2. So the area is the base, which is 4. The perpendicular height is 3. I know that because it's at 90 degrees. And then you must divide by 2. This 5 centimeter side, which is the slant height, has nothing to do with the area. So 4 times 3 is 12. Divided by 2 is 6. And because each side was in meters, the area is in meters squared. Another way to think of this, I could fit 6 squares inside this triangle where each square was 1 meter squared. All right, let's now look at a worded problem. So let's say a farmer wants to make a paddock using 50 meters of fencing. The width of the paddock is 10 meters. Firstly, what is the area? So let's draw a picture of this rectangular paddock. So the paddock uses 50 meters of fencing, so it's going to be 50 meters around the outside. So we're told the width is 10 meters. So this width here is 10 meters. If I want to find the area, I need to know the length. So if it is 50 all the way around, that means that the length and the width must add to half of 50, which is 25. So the length must be 15 meters, because 15 plus 10 plus 15 plus 10 equals 50. So what would the area be? Well, it would simply be length 15 times width is 10, which gives us 150. Because the sides were in meters, then the units will be meters squared. So you use centimeters, meters, millimeters, kilometers for perimeter. You use centimeters squared, millimeters squared, kilometers squared, meters squared when we're talking about area. So how much will it cost to turf if it costs $22 per square meter? So what that means is I'm just going to cover this paddock in grass, $22 per square meter. Well, there's 150 square meters at $22 per square meter. So using our calculator, we get $3,300, and there we've answered the question. All right, let's now move on to volume. So length is a one-dimensional quantity. It's the length around the outside of the shape. Area is a two-dimensional quantity. It's the amount of space inside a 2D shape. Well, volume is a three-dimensional quantity. It's the amount of space inside a 3D shape. So we only looked at the volume of prism. So to find the volume of a prism, you times the area of the base by the height. So for rectangular prisms, to find their volume, you just multiply the length, the width, and the height. So let's find the volume of this shape here. So note, this is a cube, which is a special type of rectangular prism. A cube is a rectangular prism where all of its edges, all of its sides are equal. So the volume is length is 12, width is 12, and height is also 12. So if we put that on our calculator, we get 1,728. Now, volume's in cubic units, so it won't be centimeters squared, it'll be centimeters cubed. So let's find the volume of this shape here. Well, what we're going to do is first find the area of the base. So the base of a prism is the shape that's repeated at the front and the back. So this that I'm coloring in blue, this happens to be the base of this shape. So this is a composite shape. We're going to find its area. So a composite shape is just two shapes stuck together. This is a rectangle plus a triangle. So to find the area of the blue face, all I need to do is find the area of the rectangle and add it to the area of the triangle. So the area here of this rectangle is just length times width. And the area of this triangle here, well, if it is 18 meters across here and 20 meters here, that means there's an extra 2 meters here. So the area of the triangle is base times perpendicular height divided by 2. So the area of the base here is 304 meters squared. So to find the volume, I just times the area of the base by the height of the prism. So here again, this side is perpendicular to the blue face. So the total volume is just 304 times 5, which will be 1,520. Volume is always in cubic units. So there, I'm done. Let's look at our worded question involving volume. So I have this fish tank here. I'm going to pour 1260 litres into it, and I want to know what will be the depth of water. So what I'm really asking is, so I pour in the water up here. So all of this below is water in the fish tank. So what will be the depth of the water? Will it be 50 centimeters or 70 centimeters? I know it must be less than 1.2 meters, but I want to know how high the water will reach. So how am I going to do that? Well, first thing I need to do is convert 1260 liters into meters cubed. So the rule is 1 meter cubed is equal to 1,000 liters. A meter cubed is bigger, much bigger than a liter. If I want to go from liters to meters cubed, I'm going from a smaller to a larger unit. You always divide when you're going from a smaller to a larger unit. So if I divide 1260 by 1,000, I get 1.26. So I'm actually pouring in 1.26 meters cubed of water into this fish tank. So what will be the depth? What will be the height of the water? Well, I know that the volume is the area of the base times the height of the water. So if I want the volume to be 1.26 meters cubed, the area of the base is 2 meters. Now I have to change this to meters, so they're the same unit. So 70 centimeters is 0.7 meters. So this here is the area of the base, and I want to find the height. So what I have is 1.26, 2 times 0.7 is 1.4. To solve this equation, I just go 1.26 divided by 1.4. I get h equals 0.9 meters. And if I times by 100, that's 90 centimeters. If I pour in this much water, the water will reach up to 90 centimeters. The water will be 90 centimeters high or 90 centimeters deep. So whenever you're trying to find a dimension, like a length, a width, a height, from the volume, area, perimeter, whatever it is, it might be helpful to write the formula, substitute in everything you know into the formula, and rearrange for the thing that you don't know. All right, that's enough for measurement. Let's go on now to probability. So with probability, we always talk about the sample space, and the sample space is just a list of possible outcomes. When you're writing the sample space, you must use these squiggly brackets because they indicate in maths that we're talking about a set. We're talking about a set of outcomes. So to write all of the outcomes here, I can write red 3 times. There are 3 reds, 2 blues. I don't have to write the whole word out. That will take too long. 2 greens and 2 yellows. It is also okay if you just wrote red, blue, green, or yellow, but technically this way is better. So there are 3 ways I can get red, 2 ways I can get blue, 2 ways I can get green, and 1 way I can get yellow. So you will often be asked to calculate probabilities. So when you're asked to calculate a probability, you must give an answer between 0 and 1. If I ask you what is the probability of something, you must write a fraction or a decimal between 0 and 1. You can't write, say, 2. You can't have a probability of 2. Why not? Well, 1, a probability of 1 means the event's certain. So you can't get better than certain. And a probability of 0 means the event is impossible. So if an event has a probability that's closer to 0 than 1, we say it's unlikely to occur. Events down here, it's more likely that they won't occur. If an event has probability a half or 0.5, we say it's an even chance. It's just as likely to occur or not occur. And events that have a probability closer to 1 than to 0 are likely to occur. It's more likely than not that they will occur. So how do you actually come up with the number and calculate the probability? Well, the probability of an event is the number of ways it can occur over the total number of events in the sample space. So for example, if I spin this spinner, the probability it comes up as red, well, there are 3 ways it can come up as red, 3 reds to choose from out of 8 in total. So 3 out of 8, you can write it as 0.375. Notice I've given a number between 0 and 1. So red has a probability of 3 over 8. So 0.375 or 3 over 8 is actually down here. Red is unlikely to be spun. Even though red is more likely than all the other colors, blue, green, and yellow, it's still unlikely that you will land on red. So what is the probability of blue or green? Well, what we have to do is count all of the slices that are blue or green. So there's 1, 2, 3, 4 that are blue or green out of 8 in total. Now, when you're writing fractions, they must be simplified. Your calculator can do that. So the probability of blue or green is half or 0.5. So it's here on the number line. There's an even chance of picking blue or green. You're just as likely to pick blue or green as you are to not pick blue or green. So what would be the probability of not yellow? What's the probability if I spin this spinner, I don't land on yellow? Well, there's 1, 2, 3, 4, 5, 6, 7 ways I cannot land on yellow out of 8 in total. So 7 over 8 is 0.875. That's actually quite close to 1. 0.875 is up here. So the probability of not getting yellow is likely. It's much more likely you will not get yellow than you will get yellow. Probability is close to 1. The probability isn't equal to 1. It's not certain that you will not get yellow. It's just very likely that you will not get yellow. All right, let's now look at the difference between theoretical and experimental probability. So what we actually calculated on the previous slide was the theoretical probability, the fraction of times we expect something to happen. So for example, on the previous slide, we calculated the probability that the spinner lands on red is 3 over 8. That means that I expect if I spin the spinner heaps of times, I will land on red 3/8 of the time. That may not be what happens in practice, however. The fraction of times something actually happens is called experimental probability. So to highlight the difference, let's look at this example. So let's say I toss a coin 100 times and get 92 heads. So the theoretical probability of heads is still a half. Each time you toss a coin, there's 2 things on the coin. There's 2 elements in the sample space, heads and tails, and one of them is heads. Okay, so each time you toss a coin, it seems there's a 50-50 chance of getting heads or tails. But here, if I toss a coin 100 times and get 92 heads, the experimental probability is 92 over 100. And of course, that simplifies to 23 over 25 or 0.92. So this is the proportion of times something actually happened. I got heads 92% of the time. This is what I expect to happen. I expect that if I toss a coin heaps of times, I'll get heads half the time and tails half the time. Now, if there's a big difference between these two, and there is, if I tossed a coin 100 times, I would expect to only get 50 heads. So what you might conclude is that the coin is probably biased. It's very unlikely that you would get 92 out of 100 heads if the coin was fair. All right, let's look at this example here. So let's say the probability of rain tomorrow is 0.2. What does that mean? Well, what it means is if you had heaps of days with weather conditions similar to what you get tomorrow, you would expect to see rain on 20% of those days, because 20% is 0.2. So what's the probability it won't rain tomorrow? So that means that the probability it won't rain is just going to be 1 minus 0.2, which is 0.8. So if there's a 20% chance of rain tomorrow, there's an 80% chance that it won't rain tomorrow. So these numbers here are theoretical probabilities. They're what we expect to happen. I expect that if there were conditions like tomorrow, I would see rain 20% of the time. It doesn't mean that I necessarily will see rain 20% of the time. It's just that's what we expect to happen. Theoretical probability, what we expect to happen. Experimental probability, what actually happens. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.